Today we'll be doing the integral from 0 to 1 of 1 divided by 1 minus x squared times the natural log of 1 plus x divided by 2x dx. And to start off, we'll make a substitution. So we're going to let 1 plus t equal 1 plus x divided by 2x. But that means that t equals 1 plus x over 2x minus 1. But that means that t equals 1 plus x over 2x minus 2x over 2x, which is 1 minus x divided by 2x. So we have t is 1 minus x divided by 2x. And solving for x, we have 2xt is 1 minus x. That means that 2xt plus x is 1. Factor out an x, we have a x times 2t plus 1 equals 1. So solving for x, we have x is 1 divided by 2t plus 1. So now from here we could find dx. So dx will be negative 1 divided by 2t plus 1 squared times the chain rule, so we're going to have an extra 2. And the bounds of integration, t1 will be 1 minus 0 divided by 2 times 0, which is 1 over 0, which is approaching positive infinity. And t2 will be 1 minus 1 divided by 2 times 1, which will be 0 over 2, which is equal to 0. So that means that t is going from infinity to 0. And from this, we could transform the integral now. So we have the integral from infinity to 0 of 1 over 1 minus x, but that's going to be 1 over 2t plus 1 quantity squared, the natural log of 1 plus t. Dx is negative 2 divided by 2t plus 1 quantity squared dt. And we're going to use this extra negative to flip the bounds of integration. So we have the integral from 0 to infinity of 1 over 1 minus 1 over 2t plus 1 squared. We have the natural log of 1 plus t times 2 divided by 2t plus 1 squared. So we have twice the integral from 0 to infinity. And cleaning this up a bit, we have a 2t plus 1 squared. And we have a 2t plus 1 squared minus 1. The natural log of 1 plus t times 1 over 2t plus 1 squared dt. And as you can notice, these end up canceling. So we have twice the integral from 0 to infinity of the natural log of 1 plus t divided by 2t plus 1 squared minus 1 dt. And we can actually simplify this denominator. 2t plus 1 squared minus 1 is the same thing as 4t squared plus 4t plus 1 minus 1, but these cancel. So we have a 4t squared plus 4t. We could factor out a 4t. We have a 4t times t plus 1. So we can rewrite this as twice the integral from 0 to infinity, the natural log of 1 plus t, divided by 4t times t plus 1 dt. We have a 2/4 the integral from 0 to infinity, the natural log of 1 plus t, divided by t times t plus 1 dt. But 2/4 is a half, so we have 1/2 the integral from 0 to infinity, the natural log of 1 plus t, divided by t times t plus 1 dt. And from here, we'll make one last substitution, and that is z equal the natural log of 1 plus t, but that means that e to the z is 1 plus t, and e to the z minus 1 equals t. So solving for dt, we have dt is e to the z dz, and for the bounds of integration, we have z1 is the natural log of 1 plus 0, which is the natural log of 1, which equals to 0. z2 will be the natural log of 1 plus infinity, which is approaching the natural log of infinity, which is infinity. So z is going from 0 to infinity. So now making the transformation, we have 1/2 integral from 0 to infinity of z divided by t is going to be e to the z minus 1. T plus 1, that's going to be e to the z. And dt is e to the z dz. And these end up canceling, so we have 1/2 integral from 0 to infinity of z divided by e to the z minus 1 dz. And from here, we'll make use of an identity. So we're going to use that integral from 0 to infinity of z to the s minus 1 power divided by e to the z minus 1 dz. This evaluates to the gamma function evaluated at s times the zeta function evaluated at s. So comparing the exponent, we have s minus 1 equals 1. So that means that s equals 1 plus 1, which is 2. So our integral is equal to 1/2 the gamma function evaluated at 2 times the zeta function evaluated at 2. 1/2 times the gamma function at 2 is 1. And the zeta function at 2 is pi squared over 6. And 2 times 6 is 12, so we have pi squared divided by 12. And so that is the final result to the desired integral. Thank you very much for watching.